Good evening, everyone, and welcome to Light Night, the annual event organized by VUB SPIE Student Chapter. I'm Youssef Pourvais, and I will be your host tonight. I hope wherever you are sitting tight and comfortably, because tonight we are going to have two interesting talks with brilliant speakers focused on the market and business aspects of photonics. I should let you know that today's lecture will be recorded because some of the interested SPIE members from other countries were asking us to do so because they couldn't join us due to time difference and classes and meetings they had. So if you have any objections to the lecture being recorded, please let me know in a message via the Zoom calls chat section. So I know that. Just keep that in mind that the lectures and the Q&A session are going to be recorded, and obviously the drinking session is not going to be recorded. Well, before we start, I should ask you to please kindly mute your microphones if you are not already on the mute. And if you had any questions during the lectures, I would like to ask you to write your questions in the chat section so that I can ask you questions from the speakers during the Q&A session at the end of the second lecture. Please mention to whom the question should be asked from in the beginning of the question for more clarity. Also, you can send your questions directly to me instead of the public chat window of the Zoom call tonight. And I'm in this call with the name Youssef, which is spelled Y-O-U-S-E-F. After the Q&A session, there will be a social distancing drinking, which I encourage all of you to take part and have fun with the other participants. With that, I'm going to give the floor to Mathilde Patin, the president of the VUB SPIE chapter. She has been one of the most frequently seen figures for us in B-PHOT during the past year, given her efforts and presence in different chapter events. She's going to have a short presentation about tonight's Light Night, as well as current and future programs of the chapter. Ladies and gentlemen, please welcome Mathilde Patin. Mathilde, please.
Thank you. I will start with a small presentation about the chapter. Can everyone see my screen right now? So I would like to welcome everyone to the Light Night, and thank you very much for joining us via Zoom, and thanks a lot to the people who will be watching afterwards. So this year we have the chance to have a logo. So here you can see then the winning logo of the logo contest that we organized. It has been designed by Agnieszka Gerej, so congratulations to her. We also thank the participants of the logo contest, who designed the different logos that you can see here. Thanks a lot for your participation and congratulations, because they were very nice logos. Concerning our photography contest for this year, we decided to postpone the deadline to the 31st of May. So if you didn't yet, you can still send us your pictures. And here you can see on the slide the three first pictures that we selected of the last year. Sorry. I also would like to attract your attention of two novelties that we have at the SPIE chapter. So first of all, it's a new email address, spievub@bphot.org. So it's the email address that you can now use to contact the chapter. And it's also an email address that will be used for official communication, and that will be also open for all external people. Also, I really invite you to join us on Slack. It's a new Slack channel that we just created. You will soon receive a link to join the Slack channel if you are one of our student members. And so in this Slack, you will be able to discuss with everyone the next events. You will be able to propose the events. And you will, if you want, be able to vote for different things. So now we have different channels that are open in our Slack. We have a channel, for example, that has been created for discussing the Light Night details, but we also have channels and discussions about the mini talks, the International Day of Light preparation events. So this is why you should join if you're interested in helping in the preparation of the various events. So our next events, as I just mentioned, is the International Day of Light that will be held in 16th of May. There is already some details that are available. First part of the International Day of Light will be a competition. So I really invite you to all participate. If you're interested, you can find the details on our Facebook. And you also get email if you are already members. There are some details to discuss about the International Day of Light. So if you're interested to join and help, you can still make part of the team. Then we also plan, of course, to have other sessions of the mini talks. Just as a reminder, the mini talks are small events during which one or two speakers will present some PowerPoint about their personal feeling about specific topics. For example, during the first session, it was about women in academia, and we had the honor to have talks from Heidi Odvar and Toba Birkan. And it was also the occasion to have discussion about how to deal with specific issues. So if you're interested in having a more informal talk about scientific topics or in scientific environment, this will be the occasion to join during the mini talks. Finally, during our meeting and also on the Slack, we will be designing SPA VUB guidelines for the future. As you can see on the picture, so we have currently also online meetings, but it's not only very strict and boring meetings, but we also have some fun, and it is the occasion to know each other and to bring everyone together again during this time of quarantine. We will also prepare many other events. You can also propose other events. You can decide what chapter can bring for you, and we also want really your opinion for each event that we will make in the future, so you're really welcome to join at any moment. Thank you for your attention. Don't forget to join us on Facebook and to join us on Slack. Thank you, and good talks to everyone.
Thank you very much, Mathilde, for your concise and very much up-to-the-point presentation. I would like to ask you all, if you have not yet, please follow the VUB SPIE Student Chapter Facebook to stay tuned with our wonderful events that you might be interested in, especially Light Night's Idea Light competition, which is going to be concluded at an event during the International Day of Light on May 16th. It might be of a particular interest to participate in the competition. Now, for tonight's Light Night, as I mentioned before, we are going to have two very interesting and useful talks. Our first speaker tonight is here with us all the way from Arizona, where I think it's around 9:30 a.m. now. He is one of the most decorated scientists in the fields of optics and photonics. His expertise is on optical testing and measurement, specifically using interferometry techniques, as well as entrepreneurship, having been involved in the startup and running of several optics companies himself. Today, he's going to share with us his priceless experiences in starting and growing optics companies. Ladies and gentlemen, please welcome from James Wyant College of Optics in the University of Arizona, Professor James Wyant.
Really most interested in. It was just a fantastic job. That's so lucky to get it. Well, I worked there for 6 years, and at one point during those 6 years, my boss left and became a faculty member at the University of Arizona. And in 1974, he invited me to join the faculty of what was then called the Optical Sciences Center. And if you look at my video, you see the building in the background. That's the main building for the what is now called the College of Optical Sciences. So I came out here in 1974 and started to work at Optical Sciences. And I taught several courses. I had some wonderful students, and we did some interesting work and published a lot of papers and gave a lot of talks. But after a few years, well, I was getting bored with what I was doing. I had gone through, and I had gone from assistant professor to associate to full professor and tenure, and I don't know, I was bored. I needed to do something else. Now, I began writing software for analyzing interferograms, and I sold that, and I did a lot of consulting. And I did built some hardware for people, for companies, but I decided I really wanted to have a real company. So I wanted to start a company, but you know, if you're going to have a company, you have to have a product. You have to have a product that, first off, something that works well, but equally important, other people have to be interested in. It has to be people who want to buy that product. So, you know, I thought for quite a while, what product can I have? Well, I visited a company that was making diamond-turned mirrors for laser fusion systems. And they were having trouble making these diamond-turned mirrors smooth enough. And I looked at how they were measuring the roughness of these diamond-turned mirrors. And I tell you, it was horrible what they were doing. It was so complicated, and it just took so much work. You know, I said, there has to be a better way of doing this. So I thought, you know, maybe if we could develop an automated interference microscope for measuring the surface quality of these diamond-turned mirrors, maybe that would be a product that, you know, we could start a company and sell. So as soon as I got back from that visit, I contacted some people at Los Alamos Scientific Labs, and they had been supporting some of the work I was doing. So I asked them if they would support my, or I should say our, development of an instrument, you know, for measuring the surface quality of diamond-turned mirrors. And they said yes, they did. So they gave me some funding. And as you know, professors don't do much work. They always get students to do the work. I learned that long ago. I got a very bright student to work with me on this. And so what we came up with was basically just a microscope system where, you know, you had an illuminator, you had a microscope objective, and then you had some type of interferometer on the microscope objective. And we use different interferometers for this drawing. Is what's called a Moreau interferometer, but the details of that don't make much difference. And then we had the sample at the bottom, which for right now would be a diamond-turned mirror. And then there was a reference spot in there, so produced a reference beam, and so you would interfere the reference beam with a beam reflected from this diamond-turned mirror, and you get interference fringes. And at this time, this was a time when detector arrays were just becoming available. So we put a detector array there and interfaced that to a computer. And then we used what is now called phase shifting interferometry, where probably many of you have heard of that, but you take 3 or more frames of data where you change the phase difference between the 2 interfering beams. And from these 3 or 4 or more frames of data, you can calculate the phase difference between the 2 beams. And from that, you know the height variations across the mirror, and you get the roughness of the sample. Well, phase shifting was something I had done at ITech very early on, but I tell you, it was terrible. It was useless. It didn't work well. The problem was we didn't have detector arrays at that time, and we didn't have computers. But now this was more than 10 years later, and now we did begin to have detector arrays, and we had the beginnings of personal computers. And so phase shifting, which had been useless 10 years ago, now suddenly became useful. Or we thought it would be anyway. And so we built an interference microscope. And this is not the very first one. Unfortunately, I don't have photos of the first one. You know, nowadays we all have our camera with us, I guess, camera with us all the time. And so we take lots of photos, but in those days, I didn't take many photos. So this is probably the second. I think this is the second microscope we made. And I love this microscope so much. I still have it at home in my garage, in fact. Anyway, this was a wonderful thing. I love this microscope, interference microscope. it was fantastic. There was only one thing wrong with it. And that is that it actually, to be truthful, it didn't work. It took data, but the data was mostly random noise. It was just terrible. If you measure something 10 times, you would get 10 different measurements. It was terrible. I remember once we took this to an Optical Society show in Florida, and we showed it to about 200 people. And there was only one out of that 200 who realized the data wasn't good. Why didn't the other ones realize it? Well, it was so slow at taking data, people would never wait around long enough to see us take data twice. So they didn't know how unrepeatable it was. So it really did not work well. The problem, I mean, we knew optics and all that, but we really did not know electronics very well. And at that time, we had to build all this electronics ourselves. And that really was what our problem was. Well, we then had what I'll say were two gifts from heaven. The first gift was, I got a letter from a man who just had gotten his PhD from Sheffield University in England, and he wanted to be a postdoc, and he knew electronics. So that was wonderful. So I said, okay, so hired him as a postdoc. Now the second thing was even greater, what happened here. We had a man from IBM stop in to see us at the university to see what we could do to help him or help IBM. And we talked about different things that we could do. And one thing he was very interested in was measuring the roughness of magnetic recording tape. And he wanted to know, could we develop an instrument to measure the roughness of this tape? Now, you know, if someone asks you, can you do something? What do you say? Well, I always say, yes, I can do it. And then later, I try to figure out how I'm going to do it. So in this case, he asked us if we could measure this tape. And I said yes. But this time I actually had an idea for doing it. I mean, this microscope that we were making for measuring diamond turned mirrors, you know, that should be able to measure the roughness of the tape, if only it would work. But, you know, magnetic recording tape is the roughness is kind of random. And I was generating random noise with this microscope. So somehow I thought maybe it would work. And so he gave us some samples to measure. And we measured these samples. And he liked the measurements. Some ways, by some miracle, the measurements actually made sense to him. And so he asked us to measure some more. And so we measured more. And then he asked us to measure more. And we measured more. This went on for quite a while. We measured a lot of tape samples for him. In some way, it was making sense to him. So one day, he came to us and said, IBM would like to buy one of these microscopes. How much would it cost? Oh, I thought, how much? You know, I have no idea how much it would cost. And so I said, oh, $100,000. Sounded good to me. And he said, okay. And then I said, well, you know, we have started a company called WYKO, and we would like to sell you this through WYKO instead of through the university. Now, this is probably what I was doing, was pretty dishonest and all this stuff. But anyway, I did it. I told him that we would build this at WYKO and sell it to him from WYKO. So he said, okay. And then just as he was walking out the door, I said, oh, and we need $60,000 up front to buy the parts. And he said, okay. And he left. And to tell you the truth, I thought, well, probably never see him again. Well, a few weeks later, I got a check in the mail from IBM for $60,000, 60% of the 100,000. I said, of course. I was so excited, you know. to have this. I rushed off to the bank to cash a check. That's where I had a problem. Now, I had told him, you know, we had started this company, WYKO. And that was not exactly the truth. We had talked about it once, but we never had actually started. And the check was made out to WYKO. And there was no WYKO. So I couldn't cash a check. So what did I do? What all of you would do. We started WYKO. And there were 4 of us who did this. Kris Huyck, who was a PhD student of mine who had just finished his PhD at that time. Steve Lang, who was a research associate working for me, and Keith was that electronics guy, and myself. And the name WYKO came from, well, my last name was Wyant, so that's W-Y, and Chris's last name is Huyck, that's a K-O, so that's WYKO. He wanted to call it Co-Y, but I said, no, it had to be WYKO. So anyway, so that's how we started WYKO. Now, and, you know, we had been doing all this at the university, which probably wasn't very good. I didn't know it. Later I'd become a dean, and I didn't realize I shouldn't do all these things, but I did it. But I knew we had to, you know, we had to be doing this someplace else. So we rented a small suite. And when I say small, I mean small. It's well, smaller than the office I'm sitting in right now. But it was something different from the university, and that started. So WYKO had 2 main goals. The first one was to have fun. And the second one, what do you think the second one would be? Make money. So we wanted to have fun, and we wanted to make money. But there was a problem. And the problem is that, first off, we were not having fun. And secondly, we were not making money. And why was that? Well, this stupid microscope wouldn't work. You know, some way we were able to measure these tapes when we were doing it, but you know, the microscope it was so noisy, we just couldn't deliver that to IBM. And so every month I would send a letter to the purchasing agent at IBM saying, I'm sorry, we did not deliver the microscope this month, but we're going to deliver it next month. A month later, I would get a letter back from the purchasing agent saying, you said you were going to deliver the microscope this month and you didn't do it. When are you going to deliver it? I'd go to my computer, pull up the letter I'd sent the month before, change the date on it, and send it again, saying, sorry, we didn't deliver this month, but we will deliver next month. Next month, you know, comes along, same thing, letter from purchasing agent. I have to go in, change the date on the letter and send it back to him. This went on for a long time. It was horrible. It just wasn't working. Now, the problem was that, you know, the 4 of us had started the company, but only Steve was working at the company. I was still full-time at the university. Kris was still working at the university. Keith was still working at the university. And so poor Steve was the only one working at WYKO, and it just wasn't going to work. So in September of '84, I decided I really had to go to WYKO, essentially full-time. Now, I didn't want to give up my position at the university. So I said I would go down to 20% time, and I would teach a course each semester, but I would spend most of my time at WYKO, 80 hours a week, I say, which is probably not far from the truth. And we worked and worked, and now we were working, we needed more space in this little thing we had. So we rented a space in a different building. Now this building, you can see off to the right there, there's another building. In that building to the right was a dentist and a foot doctor, podiatrist. Now our name was WYKO Optical. So you know what happened? We're next door to a dentist and a podiatrist. people kept coming to us and they're wanting to buy eyeglasses. And so we had to change the name. And so we took the word optical out of it and just called it WYKO Corporation. But my friend said what we really should have called it was WYKO, because it was kind of a crazy company. Anyway, we worked and worked, and we ended up with a system that worked extremely well. It took us a long time, but we delivered that to IBM, and they were very, very happy. And that particular model, we sold something like 1,000 of these. I love this so much that I have a big photograph of this at home in my living room. It was called the Topo 3D, and then we had what we call the 2D version. But, you know, we're measuring diamond turn mirrors. This is great. This is showing a measurement done, a profile. So on the vertical axis, we have the nanometers of the height, and on the horizontal axis, we have microns of what the length of the profile was. And we could do 3D maps like that. And we, you know, it really was a wonderful instrument. And we expanded, we grew to a different location. And I love the rainbow here, so a visitor took a picture of that. This was a location just across the street from the University of Arizona. So I began having a lot of graduate students working for me, and they could just walk across the street to work at WYKO. And I could walk across the street to teach at the university, and it was great. But then we outgrew that, and we ended up buying a fourth location down by the airport. So things were going pretty well, very, very pleased. Now, this instrument that we had built was good at measuring smooth surfaces. We could measure down into the angstrom type height variations, and fast, and very repeatable and just wonderful. But there were a lot of customers who wanted to measure rougher surfaces, and our instrument could not measure real rough surfaces. So we modified the instrument, and we made use of white light fringes. I'd ask you, how many of you have seen white light fringes? I hope many of you have. They're beautiful. I love them. I just absolutely love them. And you know, when you get the paths matched in the interferometer, you get the best contrast fringes. And you know, it may be a bright fringe or a dark fringe, depending on phase shifts and beam splitters and stuff. But you get the best contrast fringes when the paths are matched. So we went back to the microscope that we had built before. And in that one, we had a spectral filter. We took the filter out, so we had pretty white light. And now what we did is that we would vary the distance between the objective and the surface we're looking at. So that would vary the paths between the two arms of the interferometer. And we would note at what position of the microscope objective the fringes were the best contrast. And then we would do that across, you know, an area on the surface. And that way we would map out the shape of the surface. And we were no longer limited to just smooth surfaces. So this, which we called vertical scanning, was good for rough surfaces. And the phase shifting that we were using before was good for smooth surfaces. And I tell you, sales really took off. It was fantastic. We could measure so many things. And we made a lot of different models, but this is one model. And we would have maybe computer control stages and stuff on it too. And computer was the most important part of the whole system, I'd have to say. And so you could measure steep steps. This is something that's almost 50 microns high. And so you would just scan, and you get fringes on the top, and keep scanning, you get fringes on the bottom. And by noticing how far you scanned, to go from good fringes on the top to good fringes on the bottom, will give you the height of this. This is a print roller. Now, this is something you wouldn't think of using interferometry to measure, but there are little pits in this thing, and we could measure the depth of those pits very nicely. And so as a print roller was used, it would wear and the pits wouldn't be as deep, and then they'd have to replace it. But we could tell them just how deep the pits were. Paper. You could measure paper if you wanted to. Now, we used to go to a lot of trade shows and we'd take the instruments with us. Oh, this was so much fun. And people would bring samples by. And this is one of my favorite ones, because you'd ask someone, can you give me your business card? And they'd give me the business card. And I said, and I'd measure it, tell them how rough the business card was. Like, what? You know, they couldn't believe you could do that. But you could measure almost anything with this. That was fun. Micromachined pieces, silicon. Let's see, what else do we have here? Oh, engines. This is measuring the roughness of the engine bore, or you could measure the direction of the honing lines. And so this is where we actually took, I think, 6 separate measurements and stitched them together. And so this is for the automotive industry. Then where the money was in, well, we started out measuring magnetic recording tape, but we got into doing magnetic heads. Now, this was at a time when the personal computers were becoming much more common, and personal computers were getting hard disk drives. Everyone wanted a hard disk drive. And a hard disk drive would have several recording heads in it. And these recording heads were difficult to measure, or difficult to produce, I should say, first. And so they would have to measure every single one that was made. You know, talking about millions and millions and millions of these things. And we had an instrument that could. And we had that, you know, we sold our instrument to companies all over the world. Everyone who made hard disk drives used our instruments to measure the recording head. It was fantastic. So we had a lot of good things going, but I don't want you to think that everything was good. We also had a few disasters. And somehow they just, disasters, while they weren't fun at the time, they're more fun to talk about than the good things. So I'm going to talk about one disaster here. Now this is not an especially new idea, and it's more common now than it was back when we did it. But you can show, and maybe some of you have done this work, you know, you project lines on a surface, and then you view the lines at the different angle. And what you see is something that looks like interference fringes, where the sensitivity is much less than what you would have for a visible light interferometer. And you can vary the sensitivity of the test by varying the spacing of the lines and the angle you project at, the angle you view at. And I would guess that some of you have done this. You know, and we built a little device here using projecting interference fringes on the surface, and then viewing these fringes, and then we would shift the fringes, and we would use the same software that we used for phase shifting interferometry. And you could contour surfaces. And for example, you could, you know, here's a tin can. We would contour a tin can. Now, I love contouring tin cans, but I've never found anyone who would buy an instrument to contour a tin can. So that didn't work. You could, you know, find the shape of your hand. And this is, I remember one of my students, John Meiling's hand is right here. I know the shape of John's hand. Again, no one wanted to buy an instrument for that. So we had this wonderful product, and no one wanted to buy it. You know, what a mistake. But it was a lot of fun. It was a lot of fun. Well, one day, this guy stopped in to see us. He didn't even have a, you know, he hadn't even made an appointment. He just stopped in and said he had something he wanted us to measure for him. But he wouldn't tell me what it was. I mean, how can we do it if we don't know what it is? He just wouldn't tell us. And so I said, I have to get rid of this guy, you know. So I'll give him a tour, and then I'll get him to the front door and push him out. So gave him a tour, and the first place we went was to the lab where we had these projected fringes. And he saw what we had, and he got so excited. he took his shoe off. He took his sock off. And he held his foot up just the right height, just where the light was coming off the table. And he said, measure the shape of my foot. Well, I pressed a button, very first try. That's the results of the very first try. That's the shape of the bottom of his foot. It actually worked, first try. Then he began telling us what he wanted to do. At least back in those days, when they made orthotics, they would make a plaster cast of your foot. That would be sent off someplace. And they would then make the orthotic and send it back. What he wanted to do is to have one of these machines in the podiatrist's office, and he could measure the person's shape of the foot, send that result off electronically to a lab that had a milling machine. They could mill out the orthotic, send it back, FedEx it back, they'd have it the next day. And so he was all excited about this. So we formed a joint venture. And we developed an instrument for measuring the shape of the foot. And I love this instrument. And it worked well. It worked so well. But it was a financial disaster. Horrible. What the problem was, for us to make this instrument, we had to charge like $12,000 a piece to make a reasonable profit. And the podiatrists, the most they would pay would be $2,500 a piece. So we had a real problem here. And I think we sold 2 or 3 of these instruments, that's all. Financial disaster. But I tell you, it was so much fun. It was worth the money it cost, I'd have to say. Now, I do have some good news for you, though. I still have 2 of these foot scanners home in my garage. And, you know, if any of you are interested in buying one, I can give you a special deal today. We can talk about that later. Okay, well, that was fun. You know, WYKO was a fantastic amount of fun. We started it right at the end of '82 because we had to cash a check. I wanted to cash a check. And we sold it to VUB in July of '97. And, you know, I hated to sell it, but I really wanted, I was tired to begin with. And but I really wanted to go back to the university because I liked being a professor. So what did I learn in doing this process here? Well, big difference between a research project and a product. You know, research project, you work and you get it working once and you take some data and you publish it. A product is something you have to be able to put in a box and ship around halfway around the world, and they open it up and it works every time. Difference between the cost of parts for a product and the cost to design, sell, produce, and maintain the product. Cost of a small fraction, cost of the parts, small fraction of what you, what it really costs to make something. And amount of money required to run a company, because you have to come up with ideas, you know, things to develop. You build prototypes. Then you finally go out and sell it, and then once you sell it, you don't get paid for maybe 60 days or more. So it takes a lot of money to do it, but it's a lot of fun. Most important, you have to have a product people want to buy. You have to be willing to do whatever it takes to get the job done. You have to be good at hiring people. And you must have dedication to the company. Now, timing is very important, and luck. I think back to what we did, and luck is certainly very, very important. So I think, do I have about 10 minutes left? Is that right?
Yes, indeed. You got 10 minutes left.
Okay, good. So, you know, I went back to the university and it was a lot of fun. I put together a research group, and then I got the chance to become the director of the Optical Sciences Center, so that was good. And I put together a plan, what we'd have to do to grow the center so it could be a separate college within the university. We did that, and that worked. So I was having a lot of fun at the university. But you know, doing companies is a disease. You do one and it is so much fun. At least for me, it was so much fun. So I had to start another company. And we started a company called 4D Technology. Well, you know, again, we had to have a product. And if I go back to thinking about the WYKO days, the problem we always had was vibration. Interferometry, as you know, is very sensitive, and any vibration would really cause us to get bad measurement. That was a real problem. So when I went back to the university and put together my research group, I decided that I wanted to see if we could develop some way of getting around this vibration. And we came up with several ideas, and we published a number of papers, but you know, the ideas really were not something that you could make a commercial product for. Well, then I heard about this company in California that had developed an interferometer that was not sensitive to vibration. And so I went to see them, and that was one of the best days of my life. They had an instrument that worked well in the presence of vibration. And I was so excited about it that I took them out to lunch, took a couple of them out to lunch, and told them I wanted to buy the company. Well, the company, I say I took a couple of them out to lunch. The company consisted of 2 people. And so the company wasn't worth very much. So I was able to buy the company, and I got the people to come to Tucson. And so we started the company here, and we called the name of the company then 4D Technology. Now, it turns out that the technology they had worked, but it didn't do everything I wanted it to do. So then we had to invent more. And we did invent a way, and I won't go through exactly how this works, but in phase shifting, as we said, we take 3 or more frames of data where you have a different phase shift between the reference and test beams for the different interferograms. So we made, and the trouble with vibration, or at least in our WYKO systems where we were taking these frames of data at different times, was any vibration caused the phase shift between the different frames to not be what we wanted. And so we came up with a way of doing this where we took all 4 frames at once. I won't go through the details of just how that worked, but I can talk about it more later for questions. And so now, you know, you had 4 frames of data. If you had vibration, you know, the fringes would jump around like crazy, but there was always a fixed phase relationship between the 4 frames. And so if you could just take a short enough exposure, it would work. And so we were able to measure things very nicely in the presence of vibration. And not only that, but we were able to measure at surfaces that are vibrating, we could measure just how their shape changed with time. It was a great instrument. Well, James Webb Space Telescope. I got involved as co-chair of the optics review committee for James Webb. And so I got to know the instrument pretty well, what it was going to be. And just to refresh your memory, it's going to be, it's still not up yet, unfortunately. It was going to be 6.5 meters in diameter. And so it had a collecting area about 5 times that of the Hubble Space Telescope. And it was made up of 18 separate little mirrors. And so if you look at this, there are a lot of challenging optical testing problems there. And you know, you have to measure the primary mirror. There's a back structure that I'll show a photo of in just a minute. And you have all these separate mirrors. They have to put them together just right so they act as one big mirror. You have thermal, mechanical strain problems, vibrational problems, and so on. So there are a lot of problems testing these. And so I got to thinking, you know, I think we could measure these with the instruments, or at least the technology that we had at 4D Technology. So I dropped off the review committee and wrote a proposal to the James Webb people that we could test these. And they, after going around looking at other people, they picked us to do the testing. And so we got involved with testing the entire telescope, the secondary mirror, the primary mirror by itself. We got involved in measuring the back structure. So this is what the back structure looks like, graphite. Now we didn't need to know the shape of this, but we needed to know how it changed, if a temperature changed, or if the mechanical load changed. And so using our technology, we were able to do that. And if you look here in this, the figure on the right, the different colors represents how the shape changed when we, in this case, I think we were changing the temperature of that. So anyway, we were able to do a lot of these measurements. And here's just showing the primary mirror. If you look over to the left side, you'll see something with a couple of people standing by it. And that was one of our interferometers. No vibration isolation at all here. And we still could measure it very, very well. So that worked out very successful. And then right at the end, the final test of the optics, they wanted to take it to Johnson Space Flight Center in Houston, Texas, where they would assemble the whole thing and we would do one final test there. Well, headlines. This was in, testing was done August 2017. James Webb Space Telescope surrounding by rising floodwaters. So what happened just as we were doing the test is that Hurricane Harvey came along. So here we are in the middle of the test and a hurricane shows up. Now there's two things you could do. One is you could stop the test and wait until the hurricane is over and then do the test. Or you could keep testing right while the hurricane is going on. So which of these two approaches would you pick? Which one do you think NASA picked? Well, they said we'll continue testing right through the hurricane. Now, you know, originally when we were talking to them about doing the test, we knew there would be vibration. And I said, oh, you know, we can measure this in the presence of vibration. But I didn't realize we were going to do the test during a hurricane. But you know what? It actually worked. And so very, very, very pleased with that. That ended up working. So 4D technology, we started it in 2002. And we sold it in November of 2018 to a company called Nanometrics. So kind of my final thoughts here. I don't know if any of you are interested in starting companies or not, but I tell you, for the right person, doing a company is just a fantastic amount of fun. And, you know, I'll say the first company is the most fun, but as you do other companies, they're also a lot of fun. And I always say, you know, sometimes you make money when you do a company, sometimes you go bankrupt. And fortunately, we made a little money. But even if we had gone bankrupt, I would have to say it was worth it. It would have been worth it. It was just so much fun, you know, and I'd love to be 20 years old again and have all this ahead of me, but that's not possible. So anyway, so it's a lot of fun to think about these experiences. And it's always fun to talk about it. And so I would like to thank you very much for inviting me. And you might consider doing a company someday. So thank you very much.
Thank you very much, Professor Wyant, for your presentation. It was absolutely awesome. Now I've taken a lot of questions from the audience, and I think I will ask them in time from you during the Q&A session, if you would honor us and stay with us. Now, our second speaker tonight is from a more business and industry field. For the past 8 years, he has been the Business Unit General Manager of Robotics at ABB Benelux, part of the ABB multinational industrial group in automation, with a revenue of more than $27 billion in 2018. Tonight, he's going to tell us about the market and technology trends of robots, which are going to shape the future of industry and engineering. Ladies and gentlemen, please welcome from ABB Benelux, Kris Huyck.
Good evening, everyone, and thanks to the previous speaker. Well done, I must say. Pretty interesting and amazing what entrepreneurial challenges you are covering. So I'm Kris Huyck. I'm a Belgian citizen and working for all my career for ABB. Started in robotics some more than 28 years ago as an engineer in service, and went all the way through to general management and being responsible for a robotics unit in the Benelux. Being in robotics for such a long time, I think, and I'm really glad to get the opportunity to share with you a little bit on the future of robotics, on the market, and also the technology trends. And I have to say, I'm going to focus on industrial robotics. So I will not talk about exoskeletons, drones, and all the other devices that are most likely calculated or counted as a robot. Within ABB, we focus on industrial robots, and this is also what I wanted to cover for this evening. Future of robotics market and technology trends. First of all, I want to have a small insight in the market challenges. And I'm looking into the robotics sales over the past years. And what I show you here is it's coming from the Industrial Federation of Robotics, which is the organization that is collecting all the information from the industry and bring it together and give some insight in what is happening. So what you see here is the sales of number of robots over the last years. And you see here from 2013 up to, and that's prognosis to 2022. But over the last years, and that is up to 2018, we see an annual growth of about 20%. And that's a very steady growth. That has been a very steady growth. And what you see here is that the business was, or the industry was automating quite heavily in robotics. From even in 2018, we exceeded globally over 400,000 robots sold in 1 year. I still remember the times where we were very proud as an ABB to sell 10,000 robots a year. So times has changed. 2018 is a little bit a change in the picture, and you see the data I'm showing you is from 2019. The new numbers are not available today. I'm expecting them over the next month. IFR was even predicting 2019 would be a steady situation. But I can tell you 2019 was not steady, and it declined. Market declined by about 16%. And that is also confirmed from other competitors that the market went back. Where it comes from, I will come later on. Where do the robots end up? And we look here in the segments, the traditional segments. Pretty much robots end up in automotive. Market grew over the last years, became steady, But in 2019, automotive didn't invest. And they didn't invest basically because of uncertainty in the market, difficult market, because what is it going to be? And I'm aware about differences over the globe, but when I'm looking at Europe, for instance, there is diesel ban, so diesel cars are not allowed anymore in the city centers. We have, people moving into electrical, but electrical is not for the normal people. They cannot afford it. There is no infrastructure everywhere. So they have to maintain 3 platforms: diesel, gas motors, and also electrical vehicles. And this is, of course, for them difficult. They cannot maintain 3 platforms, and they do not invest. They don't know where it's going to lead to, and they don't want to invest. And this is basically still going on in 2020. Then you see a big chunk of robots going into the electronics over the last years, although 2018 has been a drop. And that comes from the fact that the robots or the electronic industry, is just about satisfied. People have their devices, and it's only replacement of equipment. For the rest, traditional industries like metal and plastics, they still continue to invest in robots. Growing is food. The need of food is big, and the market is also growing. And that's also because of the fact that people, or the number of people on the globe, is growing. So we all have to feed the people. That's basically where robots end up, and the explanation of the stagnation or even the drop down in 2019, 2020. Looking further, and that's of course prognosis. End of last year, they did a prognosis of a growth of 10% for 2020. Everyone today knows, due to Corona, this will not going to happen. And we even fear a decline of over 30% of robotic sales over the globe. But in normal circumstances, we predict that things are going to take off. They are going to take off not in the traditional industries, but they will take off in new industries like medical, logistics, and also field robots. These are new areas of robot investments and automation needs. That was a little bit on the market, robot market. Next step, I wanted to talk about the challenges of the manufacturing industry, and that's a specific industry. It's an industry of big and smaller companies. Here in Europe, manufacturing industry is also one of the most important industries to maintain labor in the countries. And it's also very high, or very much linked to know-how. The more know-how is in the country, the more manufacturing industry is kept as a base, and also labor is kept in the country. The manufacturing industry, however, is facing some challenges, and I want to list them up here a little bit. The first one is they have to cover 4 generations of people, and from the left to the right, all the people have their own standards. They have their own values, and they want to be treated on their own way. Elder people, they are used to buy things, where younger people want to share things. So that's it's a challenge. It's a challenge that needs, or that will lead to changes, even more than today. Another challenge is regulations. I mentioned one already. It's like diesel ban. Regulation will shift or can shift behavior of customers. If, for instance, loading infrastructure for electrical vehicles is available, people tend to move faster to electrical vehicles. So governments and regulations are influencing decisions for manufacturing industry. Another challenge is disruptive competition. Over the last years, we have seen some examples of it. Traditional industry is waken up by some new players, like examples Uber, Tesla, software companies, insurance companies. At once they step into a certain business with totally new ideas, totally new models, and they make a change, or they start a change in the industry. Also, the supply chain for the manufacturing industry is changing. As an example, I took 3D printing. 3D printing enables the supply chain to produce fast and very close to the manufacturing companies. And last but not least, since software becomes the new hardware, industry need to take care about safety, security, and that's a new challenge for them because they are not used to. Apart from the challenges, the manufacturing industry also faces some uncertainties, and it's quite amazing, in fact, the changes they are, or the uncertainties they are facing. People want to, we all start to have a different behavior, shopping behavior, buying behavior. We want to have unique goods, personalized goods. We want to have it fast, and we want to have it on demand. So this is all not coping anymore, or we cannot cope anymore with the traditional way of manufacturing. Traditional lines for big volumes are not applicable anymore. So industry need to change over to small production units, scalable production units that can cope with the change of demand and personalization. So this is what you see, what is happening. No big lines, but individual islands where people produce smaller batches, and by that we can cope with, industry can cope with fast changes. How is industry going to, or manufacturing industry going to, be possible to do all these changes? And that's based on trends and developments that are happening, and that will continue to happen. I first want to look a bit in today's trends and developments. One of them is robotics. Traditional robotics is high-tech equipment. You need trained people to integrate them, to build cells, to integrate them, and also to program the machines in a way that everything is running smooth. It's not about programming the movement in many cases, it's more about what if that is taking the most of the time. But if we want to grow business, and if we want to cope with the small batches and the new needs, then these equipment need to be easier to integrate, need to be easier to program. As an example here, I show you one of the things ABB has been doing. Instead of traditional source code programming way, we have developed a kind of block way programming, easy to do, no real, you don't need that much training anymore, and it's a very much look and feel what can help people to program. So by doing this, we can enter in other industry, we can enter in lower the threshold for companies to invest in automation. If you see this block programming, it's people that are used to, for instance, Lego Mindstorms, they might know it. Also Google has this Blockly programming. It's a lookalike, what we have been doing. What is also possible, and we demonstrated it, ease of programming, ease of integration. Many of you might know the YouTube movie where the robot is conducting a philharmonic orchestra. This has been done by recording via cameras the movement of the dirigent, and then with algorithms we have changed the movement into programming code. So no people have not been making any code to do this repeatable or repeating conducting of the philharmonic orchestra. Another trend and development is the see and feel, sensors, cameras are more and more available in the automation. They also develop companies develop much more cameras nowadays and sensors, even intelligent sensors that can be used in the applications to make the robots deciding on their own, or to generate 3D environment where they can act and moving. See and feel end effectors. This example is a gripper from a company, a US company called Soft Robotics. What is different from this gripper from other grippers? It's capable to handle fragile objects that can also vary from shape, and it's a good technology, and it's proving now that it is well developed and widely used in industry. This kind of sensors, and this is an intelligent sensor, it's able to detect where the object is on the gripper and activate based on this information only those zones of the gripper for the vacuum to pick up the parts. So intelligence is embedded in the equipment, in the end effectors, and this is of course enabling a lot of new, or opening a lot of new possibilities. Another trend in the robotics industry is the collaboration, and collaborating robots. It was future, but it becomes more and more reality. The cell I'm showing here is the traditional robotic cell. It's a total production cell with cage around it, so it's 100% safe robot application. On the other side, we have the full open collaborative robot working together with people, with humans. This robot is intrinsic safe, so it is allowed and capable to move to operate together with people. In between, you have a complete area of collaborative robotic solutions, that collaborate with humans in a way that when people enter a zone or come too close, the robot will slow down or even stop in certain cases. From left to right, the degree of collaboration is increasing, but on the other side, from right to left, the speed of production is going from low to high. And this is an area, or this is the that people need to know. If you want to go full collaborative, you cannot produce as many as you do with a normal traditional cell that is fully caged. There are a lot of applications in between, and yeah, we are at the start of it. People are trying to find out what is applicable to them, and they really make steps in the collaborative area. Another trend is, of course, the remote analysis and monitoring. We are capable to do fleet monitoring to keep an eye on our customers' install base, and even inform them if that something is going to happen, making them able to stop the production, repair it before they get an unplanned stop, which is causing a longer standstill. So from unplanned standstill to planned standstill. This is about what we are, where we are today. Now, what is tomorrow going to bring? And this is happening now, and it will continue the weeks or the months in front of us, and the years even. Traditional production is, it's the caged production. People are automating parts of their production. This is moving to fully automated production lines, but flexible production lines. Depending on what the customers are ordering, the goods are brought on movable platforms to the robot production cells, and then they are producing the numbers and the speeds that are required. This is starting to take off. Also in automotive, we see this is happening. And I can also mention that ABB is building a new robot factory in China that is applying all this new technology. Another trend, it's the virtual technology. What we have developed over the years is our product called Robot Studio. Robot Studio is a 3D virtual development environment, but also programming environment. So our customers can build their own production environment, cells. They can test everything, they can program everything. They can even collaborate with virtual teams in the tool. They can step into it. They can see how things are behaving. They can see if things are possible or not. And we see this is really taking up. That also in Corona time, people move faster in this kind of technology. This is then leading to a digital twin. If you are really building up in the virtual world and programming there, you can simulate before you buy. And this is a full digital twin, what you see here. The virtual environment is doing exactly the same as the real environment, or the opposite, whatever side you would look at it. Another development is augmented reality. And what you see here is an example of a projection of a new development or a new design. The customer here is projecting two robots virtually via augmented reality in an existing production line, and by that being able to check for collisions, but also for capacity and other things. So nothing is disturbing the real installation, the real production. Via augmented reality, we are able to see and test and check what we want to do. Another area of development is the augmented support. This is support from distance, from remote to our customers or in between colleagues over the globe. And there are different devices that can be used, and we all know the Google glasses. What we prefer today is the devices like iPads or phones. Those things people have and are easy to handle and able to connect. For your info, we are actually supporting our customer Volvo cars around 24 hours a day. They can call us and we support them via this augmented support. So it's proven technology and it's now taking off to other customers. Next level of development is the digital factory. And I took this picture from Fraunhofer Institute, who are present at the University of Twente in the Netherlands. They have developed a model of digital factory. On the bottom, you find the real production environment. The first digital level is the digital twin, what they call. Above that one, you have the digital prototype. And you see the digital twin is matching the real environment. The digital prototype is what we want to build in the future as a company. And then the digital master is containing all the data that is needed to build the digital prototype. So this is technology Fraunhofer is further developing, and they are capable to do this kind of digital twinning for their customers. As an example, I took on development, I took deep learning. Deep learning is maybe people don't know it, but it is widely used as object recognition in public areas. If you enter, for instance, an airport, they are having a massive amount of cameras, and they are really looking into the environment. They are checking all the objects, and they are, for instance, checking for abnormal behavior of people. And of course, bomb attack in Brussels in 2000, I think it was 2017 or 16 even, was increasing the development of these kind of technology. This technology industry is capable to adapt or adopt, and this for an area of quality inspection. Quality inspection in manufacturing industry, but also, for instance, quality inspection in agriculture. People today handling your tomatoes or cucumbers, they are capable to do visual quality inspection. Machines today still have problems with that. But we are moving, and we are moving in the right direction, and it will enable automation also in this area. What I show you here is an example of something we developed as ABB ourselves via deep learning. We are capable to recognize the objects in the box, and we define a grabbing strategy for arm left or right of the YuMi robot. Two different grippers, on one side the suction cup, on the other side and servo gripper. So the camera recognizes the objects, and then the the grabbing strategy is defining what arm is picking what object and where it needs to be put. The video here is 5 times faster than what the reality is, but we are really moving into the right direction for speed in this area. Okay. Then, yeah, something completely different. Nice developments in cameras, in sensors. But what about IoT? And in the industry, we have factories filled up with machinery, manufacturing machinery, with robots, with control systems, even PLCs, sensors. Most of the time we also have warehouses and logistics. And all of this equipment is now starting to be equipped with a lot of sensors. And all these sensors, they provide the companies a lot of data. And many of the companies now started just to collect and store the raw data. And if you don't do anything with it, then you're the owner of raw data. So it's now very important to come to a next level, and that is extract information from the raw data, information that can be used to support people in a manual decision. Get insight in what is happening in your factory, in your processes. If you then go one level higher and you can give advice based on information you gathered, then you remain in a supportive mode, but you can do manual actions based on this advice. And as a top level, if you reach that, then you go in automated actions based on advices, and then you can start on autonomous actions. This is the highest level of information, of know-how, and as you see from bottom to top, value of the data and information and advice and action is going up with the pyramid. The higher in the pyramid, the higher the value. How is this possible? Because a lot of companies today are still on level 1, level 2 is starting. Level 3 and 4 is not that often reached today. How is this possible? Gathering all the data. It's possible via the industry of things, the IoT, industry 4.0, digitalization. And of course, technology is supporting collection of data. One of the technologies that is supporting, or that will support in the future heavily, is the 5G technology. And no, it's not the cause of COVID, because many people tend to make the link. It's technology that will support from low band to high band data transfer, and with a low latency, so it's very fast transferred, and it will enable us to bring the data and then also analyze it and bring it to a higher value in order to use and to steer and control our processes, our factories. All of this is leading to new applications, and took some examples that are actually going on for the moment. New applications like waste treatment. It's a lot of governments really push in this direction, that the fraction of, like for instance, metal, heavy metals, and all the other renewable materials bring money instead of cost money. when you take them out of the waste cycle. So waste treatment is one of the areas that is taking off and which will help us to be greener on the globe. New applications in food, and then I'm looking really at this restaurant companies, McDonald's, KFC, and others. They are really looking into the robotics automation because people are very hard to find, people are hard to keep, and people are costly to train. And if I say that making your French fries at McDonald's is one of the biggest challenges for them, then you must not be surprised that they start looking at automation. And then last but not least, one of the areas, and it's, I think now today, Corona is one of the examples where robotic help is very needed. It's in the laboratories, in the hospitals. We are developing some robots that are on a movable platform that can support laboratory people focus on their core business and also help nurses to be more efficient and then give them time for the patient instead of removing dishes and all this kind of logistic stuff. By having said that, manufacturing industry is really looking, it's challenged. There are uncertainties, but they have really a bright outlook, looking at the developments, the trends, and what everyone is doing to bring ease of use, ease of integration, the robotics, automation closer to the people and supporting on our day-to-day needs. So let's write the future. That's our motto. Let's write the future together, because it's not about us, it's about all of us bringing this to a higher level. Thank you very much.
Thank you very much, Kris, for your very nice presentation. I think we can start our Q&A session right away, if also Professor Wyant is available. So I have received 16 questions until now, and I will start to ask the questions from top to bottom, of course. And if we don't have, I will stick to ask questions, one question from everybody, because some people had multiple questions. And then if you have time, we go the second round and so on. Okay, so the first question is from Professor Wyant. Let me unmute you. Yeah, the first question is from Professor Wyant. Do you hear me, sir?
Yes,
perfect. The first question is, what's the dimension of the interference microscope? I think they meant the one that you showed a photo of, and you said you got one still in your backyard, the very first photo of the interference microscope that you've shown.
And the question, what was the field of view, or?
The dimension of the device in itself.
Oh, the device itself? It was probably half or 2/3 of a meter high, and the width is maybe 15 centimeters or so, 15, 20. And then there's electronics box and power supply and so on too.
The second question is that you have mentioned that you have 2 gifts from heaven, and both gifts were people. What is your hiring strategy?
Well, I mean, certainly people are that's the most important thing, is hiring the right people. And so I hired at the beginning, I tried to hire people who had good experience. had worked for a good company. As time went along, I hired a lot of people from the University of Arizona who I knew. I always hired the smartest people. You know, you want to hire people smarter than you are yourself. So always tried to hire the smartest people that I could get. And every now and then you make a mistake, and it's important to correct that mistake as fast as possible. So there were a few people I had to let go, but very lucky on the people we had. Hired some, as we went along, and needed some business people. You try to hire people who fill in spots that you can't do yourself. So hired some business people to help, and salespeople and so on.
Excellent. The next question is that you've mentioned that you were brave enough that when they asked you if you can do something, first you say yes and then you think how. And it said that I usually sometimes do the same thing, but I sometimes think that it is too brave and I can get punished.
Well, I say that. I mean, I would think a little bit about it first to make sure that I think I could do a good job at it. But I generally will say, yes, I can do it, and figure out later how to do it, or get help in doing it.
Okay, perfect. So let's ask a few questions from our second speaker, and then we will come back to you, sir.
Okay.
Okay, Kris, can you, let me please first unmute you. Kris, can you hear me?
Yes.
Yes. Okay, the first question we had from you was that, do you think that because of the current situation, the food robot sales would increase as well as other robots that could replace the manufacturer?
Yes, I'm fully, I fully believe this is going to happen. If you look in the food chain, people are, first of all, food need to be safe. So the more people that are in contact with food, the more risk there is to contaminate the food as such. Secondly, if you look at the growers, like for instance in greenhouses, people that are harvesting, they are hard to find. People have to work in summer in 50 degrees, humidity environment or humid environment. They are simply not there anymore. People don't want to do this job. So those growers are desperately looking and waiting for solutions with robots.
Thank you very much for your answer. The other question was that, how do you foresee the role of optics and photonics in future of robotics?
Ooh, that's a difficult one. It is actually already in looking at some applications like laser welding. Of course, it's some niche applications that really use this kind of technology. And the more development that takes place in this area, the more applications that can be developed and used. So it will be the technology that drives the use of this technology.
Excellent. And I have another question for you, Kris, and then we will switch back to Jim, and then we will see. They said, thanks, Kris. Very interesting to see several lean production techniques applied, such as the smaller batches and stop if error. To produce these smaller batches, you mentioned 3D printers are uprising. So do you currently use 3D printers to produce certain parts of robots?
Not yet, since the volumes are pretty high, we produce. But definitely we use it in prototyping. So it enables us to go for a rapid development check and these kind of things. I'm convinced that in the future, 3D printers will be used to create or to make spare parts.
Oh, Thank you very much for your answer. If it's possible, we can go back to you, Jim, for more questions.
Okay.
I have here, yes, another question. Thanks for the very interesting talk. What was your marketing strategy in the early days?
Oh, wasn't very good, I'd have to say. I basically waited for people to come to me. You know, what were they interested in? I mean, that's the way it started with IBM and a lot of other sales that we didn't do a real good job selling, but fortunately we had a product that people wanted. And so they came to us. And then we went to a lot of trade shows, went to, you know, SPIE shows, a lot of exhibits. That was always fun.
Excellent. Well, we have also a fun question from you. They said, how many % off that food scanner?
How many what? How much?
How many % do you sell off that food scanner you mentioned?
How many did we sell?
How many % would you offer if anybody's interested to buy?
Well, I don't know. That's, we have to sit down and discuss this.
Well, another question was that, well, extremely good talk, many thanks. As a graduate starting their career, should one target a large scale company or a small or medium scale or startup company? Where is the learning experience better and why?
Well, I think, you know, you want to go to a good company. You want to go to a company that has very good people, people that you can learn from. I think that is so important for the first job. You think you know everything and you know your schoolwork, but there's so much more to learn. So go someplace where there are plenty of people you can learn from in the technical area, but also I think in the business area. I don't know if it depends too much on the size as it does just the quality of the people.
Okay. Another question was that, thank you for the inspiring talk. What do you consider the biggest challenge, or maybe a few of the biggest challenges, on the entire way of running your own company?
Money,
Really?
and money, yeah. Having enough money to pay the people and to build the products you need. Hiring the right people is always a challenge. And you know, having a product that people want to buy, and have something about your product that's special that you can lock out the competition.
Very well. I would ask you another question, and then we will come back to Kris because there's also a few questions left for Kris. Yes, we would have another one. Yeah, I found it. Based on what do you decide on doing the next product? What really inspires you for the next product, whether the aim of the device or the physics behind it?
Next product now, or doing the company?
I think they meant it in general now, or.
Well, kind of look at you know what people are asking for, and I probably should have said this before, but you know, your salespeople, once you get salespeople, you want to really listen to them because they're talking to the customers and they know really what the customers want. So you certainly listen to the salespeople. I mean, sometimes I did things because they were fun to do, and probably from a business sense that wasn't the smartest thing. But it made it a lot of fun, I'll say that much. But it's really just see what you think people want to buy. And it's nice if you can get someone to buy a system and to pay for the development of it. And that happened a lot of times for us. And then we really got in with IBM. I mean, we sold IBM so many systems over the years. I can't even guess how many, but they helped us a lot. And there are other companies that helped us a lot too.
Interesting. This is a question that came to my mind also, given the pictures that you've shown with the very stylish computers that you had on device. Which programming language were used for the first models?
Oh, boy, go back to the first model. Well, the very first was BASIC. I don't know that we ever sold anything using BASIC. We used Pascal for a while, and then C came along, and that C was really what it was done. I wrote the initial software, but then I quickly learned I could hire people who could write much better software than I.
That's true. That's really true. Thank you very much, Jim. We will go back to you if we had time, because we have also other questions. There are a few more questions from Kris if you have time. Let me unmute you. Okay, so Kris, the question is that, thank you for an interesting talk. What about limitation of human behavior, thinking and emotions in the robots? Do you think the movies about the robots' rebellion will one day become true?
I hope not. First of all, because who will then be the one to blame? For sure, if you're in the US. But the more intelligence and self-decision possibilities we will add to the devices, if you accelerate that, then you end up in this kind of situation. Yeah, possible.
So you see it possible, actually.
I think it's possible.
Wow, yeah. that's scary.
Yeah. If I might take the liberty, I found one of the previous questions very interesting. Yes. Where do you want to start your career? Mm-hmm. In a small company or in a big company?
Yes, yes.
And Jim really hit the nail at the right place. You need to be in a place where they have money.
Oh.
But there are two different strategies. You have small companies that are really developing things, like startup companies. It's a totally different mentality and environment than in a big company like ABB, where things need to be much more in line with what the company is expecting. And it's two complete different worlds. One is the development is entrepreneurial. It's really, if you need something, you go to the shop and you buy it. In a big company, it's not possible. There you have to make a purchase order, and then you have to wait for the equipment and blah blah blah. So it's interesting. Yeah, really get surrounded by people, as Jim mentioned, that can support you in growing. That's one of the most important things.
That's a very interesting point of view indeed. There's a question that is aimed at both speakers, so I would ask it from you, Kris, and then we will shift again to Jim to ask the same question and continue the session. Thank you very much for the very interesting talk. Are any industry-related specific challenges for you due to the recent corona outbreak? Any challenges for you personally for this during the outbreak? Did it have an impact on your research strategies? So yeah, I think the question is, how did corona really impact your job?
Yeah, it's impacting us as many companies. It's people due to the fact that we cannot collaborate in the same way as we did before. People are not deciding that fast and that much anymore, so it has an impact on the buying pattern of our customers, of course. Does it have an impact on us as a company? Yes, I think we learn to work from home remotely, and that there are really much more different and ways to collaborate, to work together, to not to spoil time in traffic. And then I'm really referring to Europe, Benelux. We spend quite some time in traffic. So it's extra time, it's extra life quality that you gain when you use the digital technology.
Thank you very much for your answer. I think we can switch to Jim, now with the very same question. How much do you think the coronavirus impacted your business and your research activities?
Well, first off, I'm retired, so it probably hasn't affected me as much, but I'm still involved in a lot of different committees and a lot of different associations, and I'd have to say there are some advantages that have come out of this. Not that I want to stay in this situation for a long time, but some advantages have come out. You know, Zoom is a fantastic thing. I've gone to so many meetings that I swear are better than what they were when we were there in person. And it saved a lot of travel. I'm listening to talks that I probably would not have listened to otherwise because you know, it always involved going someplace. And I can stay home in my house and go to these talks. It's also given me some time to just think at home, and I picked some projects that I'm working on, things that I've been thinking about doing for a long time, but you know, always had some reason why I couldn't do it, or I didn't think I could do it. And so it's actually is pretty good. Now, saying that, I don't want it to last much longer. I'm ready to travel again and going back more to the life I had before. But I won't go back to exactly the life I had before, for sure. And none of you will either. It's going to change how we're going to live. In some ways for the better, I think.
I have to agree with you, actually. That's I think that's one of the mottos that's recently going viral, that the standard was actually the problem before this happened, so we cannot actually go to that. And I have to say, on our part, we really wanted to have you in Brussels, but that didn't happen, so hopefully on another occasion.
Yeah, I would love to have been there, but didn't happen this time. Maybe in the future.
This time. Hopefully. Well, the other question is that how important do you think is to have a business administrator to start this kind of company? I think what they mean is like a mentor for the startups that is happening, or at which step do you think it's good to include them? Because you didn't mention that you had somebody to discuss business with and you started. So how do you think it would be for now?
Well, I think I didn't mention it, but there were a group of retired business people here in Tucson who were willing to meet with us and discuss you know, problems that we had, and they did that free because you don't have any money, so only way you can do it is free. But that helped. And then IBM had a large facility here in Tucson, still fairly large, but the man who ran that for several years retired, and I approached him to see if he would give me 2 or 3 hours a week of his time. And that helped a tremendous amount, I'd have to say. So I got help from other people.
Perfect. The other question is thank for the talk. You talked about the technical challenges you had and how you overcame that along the way. How was the experience with funding and the management in your team? Is there any occasion, for instance, along the way that you wanted to just leave the boat?
Well, I mean, the financial part is always a problem getting started, but I always say, you know, my name is James C. Wyant, and the people who know me say that the C stands for cheap. I don't like to spend money. And so I've always been very careful with my money. And I think that helps when you start a company. No, I don't know. I won't say every day was fun, but overall I had a lot of fun. And I don't think I really ever reached a point where I really wanted to quit and bail out. You know, some days you may be, oh, this is terrible, you know. But overall, it was fun, and I never seriously thought about dropping out.
Well, the next question is actually related, and it says, would you stop it if it was not fun anymore?
Yes, definitely. I mean, yes. If I'm involved in something and it's not not fun to do, I'm probably not going to continue doing it.
I'm speaking.
That's why I've had a lot of fun in life, I have to say.
I think I'm speaking for myself that I wish that we kids of these days had the same courage that as you when answering these questions. And I think this would be our last question because I don't see anything else on the chat yet. Thank you for the very interesting talk. After the success with a device for the IBM, did you know about your trick? Did you tell them? If yes, what was their reaction? I think they meant by the postponing it every month. What they mean. Did you ever tell them?
Yeah, I mean, they knew we were having trouble. I was, my contact there, Barat Bhushan, became a good friend of mine. He's now a professor at Ohio State, in fact, and I still see him. But he knew what the problem was. And IBM, they really needed this instrument, and they didn't have any place else where they thought they could get it. And so they put up with us very, very nicely. I mean, we had that $60,000 for a long time before we gave them anything. And they were just extremely nice to us. And but it was more than just a letter to the purchasing agent once a month. I had a close relationship with him.
Okay.
Well, I have a question for you, though. I have a question for you.
Sorry. Yes.
I see we have a social distancing drink. And I don't know how we do that. I've been looking for that feature on Zoom and I can't find it.
The thing is that there is a feature on Zoom to break into rooms. So I think I am in contact with Heidi, actually. She told me that, well, she managed to make something happen. So I think I have to leave the meeting and come back again and see if I can see the break into rooms button. Then we can break it randomly into 6x6 into
but
rooms.
It's a drink that I'm thinking about.
The drink, I think it would be personal refreshments. So I have a beer can by my side, so I think I'll go grab it from the fridge. I'm receiving more questions, so I think we proceed with 2 more questions and then hopefully we stop because it will be 8. The first question is, that's a nice one. Do you have a clear borders between friendship and the people who work with you as your colleagues?
You know, they work for me long enough, you know, we're friends. I mean, I have lots of people who work for me now for 25 years in different companies or here at the university, and same with a lot of the former students and I. I mean, we're very good friends. But that can be a problem at work if you become too friendly with.
I think that was the problem that was mentioned. And the last question is that, again, for you, Jim, at the end, did you know why the IBM samples were successful and the first models were not successful?
Oh yeah, understood it. Yeah, understood what the problems we had made. We learned a lot in the process.
Okay, perfect. So yeah, apparently the option is available. I would leave the meeting and come back in a second and see how we can divide this meeting into groups. Light Night is not officially ended, but the question and answer and lectures are ended. So with this, I will end our recording. And then we will see how can we manage this social distancing drinking session.
Yeah.